Hello students, welcome to Narayan PU College online classes. So continuation, previous we have already discussed the reactions of alkyl halides are divided into three categories. One, nucleophilic substitution reaction that we have already completed, and elimination reaction. In the last class we have already completed that one also. Now third one is reaction with metals. When alkyl chlorides, bromides or iodides reacted with the metal in dry ether solvent and produces the compounds containing carbon metal bond, and these type of compounds, the compounds in which carbon metal bond is there, and those compounds we will call as a organometallic compounds. Which compounds those are? Organometallic compounds. What are these organometallic compounds? Compounds containing carbon and metal bond. These compounds we will call as a organometallic compounds. Okay? The main important class of organometallic compound, is and alkyl magnesium halide, and this we will call as a Grignard reagent. Very, very important. And this was discovered by Grignard, so that's why we will call it is a Grignard reagent. And for this research, he got the Nobel Prize also. Okay. And how we will prepare this Grignard reagent? RMgX we will call it as a Grignard reagent. And take the alkyl chlorides or alkyl bromide, what iodides, what are it may be, alkyl halides. Take the alkyl halides and treated this one with the metal, that is which one here? Magnesium. In presence of dry ether. This condition is very, very important. Then what the compound you will get is CH3 and CH2 MgBr. Clear? So this is alkyl magnesium bromide. Ethyl magnesium bromide, called as a, means this type of, R means it can be anything. Alkyl group. R means which one? Alkyl group. And this is the preparation of Grignard reagent. Clear? And remember, in the Grignard reagent, it is a RMgX. Clear? And this bond is a covalent bond, but highly polar. And metal and halogen bond is a ionic bond. Yeah, this is the simple preparation of Grignard reagent. And this Grignard reagent is very, 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 very reactive. Very reactive molecules these are. Clear? And they react with the source of proton compounds very fast. Suppose, and if I take here one compound, that is the Grignard reagent I have taken, and this is treated with the proton source of any compound. Suppose I will write here water. Okay? Then you know, very important point is here, in the Grignard reagent RMgX, if this bond breaks, you know, metal is always electropositive, it donates the electrons to other, means this bond, and R means what it is, alkyl group means what, carbon. So I will write simply, suppose this is one simple example, methyl magnesium bromide, R this is, if this bond breaks, metal always electron positive, donates the electron, carbon gains the electrons. So if the bond breaks, always you remember, alkyl group gets the negative charge and magnesium gets the positive charge. Okay? And means it can act as a, in the Grignard reagent, the alkyl group can act as a nucleophile and also act as a base. It can act as well as nucleophile and base. Okay? So that's why what happened here, in this case and R minus will be there, and here H plus and OH minus. Then it donate the pair of electrons to proton, so that's why, and it will form RH plus what is there here, Mg and OHX. This is clear, because if the bond breaks here and if this is get positive, negative and positive bond, positive and negative bond, this is what the compound you are getting, alkane. Now in this case, R minus act as a nucleophile or base? Base. Yeah? Suppose if I take here RMgX, not only here water, you can write CH3OH, R you can write NH3, you can write RNH2, you can write RSH, all these are. And when it reacted with, these all are which one here? Proton source of compounds. These all are which one? Proton source of compounds. It can donate the proton. Now R minus will react with the, it donates the a pair of electrons to H plus ions, then it will be converted into RH. What is this one here? Alkane. Remember this one. In this case, it acts as a alkyl group of the Grignard reagent, act as a base. And it can act as a nucleophile also, but that we will discuss in the next topics. Clear? So this is about the what it is, Grignard reagent. Very important. This is the very good method to convert the alkyl halides into alkanes. So now we have completed nucleophilic substitution reactions of alkyl halides. Now we have to discuss about the nucleophilic substitution reactions of aryl halides. Clear? And this is one topic. And a very important question, this is for the PU examination. Aryl halides are less reactive towards the nucleophilic substitution reactions than the alkyl halides. What is the reason? That is the question they are frequently asking in the PU examination. Okay? Why means because of the four reasons aryl halides are less reactive towards the nucleophilic substitution reactions than the alkyl halide. The first one is resonance effect. The first one is what it is, resonance effect. See, we will see what is this. You know that if I take aryl halide and you know this is the, suppose I will take here chlorine. And you know chlorine is having 3 lone pair of electrons, and this lone pair of electron double bond is in conjugation, separated by single bond conjugation, so that's why they involved in the resonance. When they involved in the resonance, this lone pair of electrons convert into bond pair, and this bond pair it will go towards this carbon. Then what the resonance structure you will get here? You will get the resonance structure is, there will be a double bond between the carbon and chlorine. Carbon is losing electrons, so that's why it acquires the positive charge. And this carbon, chlorine is acquires the positive charge, this carbon acquires the negative charge, because this bond electrons moves towards the carbon. And now here there is a double bond, and here also there is a double bond. So that's why again here negative charge and double bond are in conjugation, and if they are in conjugation then involved in the resonance, then here this bond will come here and these bond electrons will go towards here. Then what the compound you will get here? You will get the compound is double bond chlorine atom, and here there will be a negative charge and double bond again conjugation, then you will get the compound is, this bond electrons will come here, another resonance structure, and this is the another resonance structure, negative charge here, there will be a double bond and there will be a chlorine positive charge and a bond here, and there will be a bond here. Next what happened here? This bond electrons will come here and these bond electrons will go towards the chlorine, and chlorine positive charge will be neutralized. Again you will get the another structure, that is, this is the compound. You will get the double bond here, double bond, and there will be a chlorine. Why? Because here bond will come and this bond will go towards the chlorine. Yeah? Then what you will get here? You will get the chlorine. You see in this resonance structure, and carbon and chlorine bond acquires partial double bond character. Partial double bond character. You see here which character? Partial double bond character, due to which one? Resonance. So that's why if it is a double bond here, then and the substitution of the chlorine means chlorine, this to break this bond it requires so much of energy, so that's why this chlorine will not easily substituted by another nucleophile. So that's why these aryl halides will show less reactivity towards the nucleophilic substitution reaction. Why? Because of the partial double bond character of the Cl bond, and nucleophilic substitution means what? And this chlorine should be substituted by another nucleophile here, and it attack here, and chlorine should go. Chlorine will go easily when if the bond alkyl halides you see, and OH minus it attack, and it will remove easily. Why? Because here which bond is there? Single bond in the alkyl halide. But here it is not a single bond, partially double bond. So that's why replacement of the chlorine by the nucleophile is very, very difficult. So that's why they show the less reactivity towards the nucleophilic substitution reaction. That is the one reason. Next one, difference in hybridization of carbon in the CX bond. If you take the alkyl halides and aryl halides, and you know this is RX. This is carbon, this carbon, suppose if I take CH3, this carbon is sp3 hybridized, and chlorine attached carbon here on the aryl halide sp2. You know that electronegativity order, as the S character increases, electronegativity increases. So what is the electronegativity order of the hybridized orbital? sp, sp2 and sp3. So that's why this carbon is more electronegative compared to this carbon. Because it is sp3 and it is sp2, more electronegative, so that's why it holds the electrons, bond pair electrons very tightly. Which bond pair electrons? Carbon and Cl bond pair electrons, and this carbon holds very tightly. When it holds very tightly and bond length decreases, it tightly means what it is? If this electron, chlorine, will not take the pair of electrons easily from the chlorine. It cannot remove easily. So that's why, and when the carbon is having more electronegative, then it holds the bond pair of CX bond very tightly. So that's why bond length decreases. So that's why bond becomes stronger. To break this bond is not very easy. So that's why they will not involve in the nucleophilic substitution reactions very easily. It involves, but drastic conditions you have to maintain. Not that much easily compared to the alkyl halides. Next one, instability of phenyl carbocation. And you know, SN1 reaction, there is another chance is there. Suppose halide is there. If it is self-ionized, then what it should form? According to the SN1 mechanism, positive charge and Cl minus. There is another chance here. If the carbocation is very stable, then and ionization takes place very fast, then involved in the nucleophilic substitution very fast. But you see, if you take the phenyl carbocation and this positive charge is not stabilized by the resonance here. Why? Because there is no conjugation, you see, and positive charge and double bond side by side only. So that's why it is not involved in the resonance. It is not stabilized by what it is here? Resonance. So that's why it is a which one here? Unstable. So that's why it is SN1 mechanism is ruled out. Clear? And last one is electronic repulsions. Electronic repulsions means you know that here halogen is there, and if it is involved in the nucleophilic substitution reaction and OH minus ion should attack here, chlorine should go. Chlorine should leave here. But you know that benzene ring is a electron rich compound. It is a double bonds are there, electron rich. And OH minus ion also which one here? Electron rich. So that's why, and here electron rich and here also electron rich. So that's why. And here when it comes to attack on the benzene ring, there will be a repulsions between the electrons. Here electron rich, there will be a repulsion. So that's why nucleophilic substitution reactions will not take place very easily. So these are the very important, this is very important question. Why nucleophilic substitution reactions of aryl halides are less compared to the what it is alkyl halides means these 4 reasons you have to write. Clear?